Hello everyone, in this article we're going to talk about how to set up closed loop fuel control. All Adaptronic ECUs support closed loop fuel, and this article explains what's needed to make it work and how to configure it on modular ECUs. First, and this should be obvious but I'm going to say it anyway, the first thing you have to do is set up your target lambda or target air fuel ratio table. If you don't have that correctly, then the ECU is going to chase for the wrong target. Secondly, you'll need some sort of lambda measurement. Now normally this would be a wideband lambda sensor, because with a narrowband all you can really do is see which side of stoichiometry you are. So you can use that for targeting lambda 1, but for any other value it's pretty much useless. Now if you're running a dual bank engine, we'd recommend enabling the separate banks selection and then running a separate lambda sensor for each bank. Make sure that you set the bank configuration correctly. So for example, if it's a GM or a Ford engine where you have an odd bank and an even bank, then set it as even odd. If it's an Allison V12, then you'll have to set it as first half, second half. Now you can also use this on an inline engine where when the front and the back halves of the engine can be treated separately. So for example, on the RB26 DETT, you can have a separate oxygen sensor on each half of the engine. In that case, you configure it as first half, second half. So that way one bank is 1, 2, 3 and the other bank is 4, 5, 6. Now in this mode and in the dual bank V engine mode, or an H engine if you're a Subaru fan, you'll need to set the oxygen sensing mode to individual. Now other articles and videos explain how to set up the oxygen sensor input, so I won't go into that here. But the ECU does have some conditions that need to be met before a lambda reading will be considered to be valid. If the input's not valid, then the ECU will just show a dash for the air fuel ratio and will force it into open loop mode. So a narrowband 0 to 1 volt sensor input needs to go up to 0.78 of a volt before the ECU will consider that to be working. A smart sensor, if you like a 0 to 5 volt wideband, needs to go up to 2.8 volts. The reason why we chose that is that many of the sensors actually read stoichiometry, so 2.5 volts on a lot of them, when the sensor's actually cold. So obviously you can't do closed loop in that condition, and if you're using an analog voltage it doesn't tell you when the sensor's not working, so that's the way we set that. Now with the Innovate sensors, they need to be sending packets obviously, and within the data packet over serial, the Innovate actually tells the ECU if the sensor's cold, if it's damaged, or if it's too lean to actually get a valid reading. So if the Innovate is actually generating a wideband lambda value and setting that, then the ECU will consider that that's okay. Now note that in a full lean condition, for example if you have the sensor in free air, then it will still display a lambda value on the gauge, but it won't actually output a lambda value through the serial stream. And you can check this by hooking it up to Logworks. You'll see that it shows an oxygen, an O2 percentage, rather than a lambda value. Now for the sensors that output serially but don't output the sensor status, for example the AEMs, Adaptronics and so on, we just need to see a valid serial stream. So that means that you really can't use that for a closed loop control because you're not going to know if the sensor's actually reading correctly, if it's still warming up or whatever. And for the CAN wideband channels, which we're going to be doing soon, they need to show that the sensor's connected and working. Now thirdly, you'll need to set up the conditions under which the ECU will go into closed loop mode. Now there are some conditions when the ECU will not go into closed loop mode, and these are as follows. First of all, if the engine's stopped or if it's cranking. If the engine's in ignition or fuel cut, there's no point going into closed loop mode because you don't have a valid lambda reading. If there's no valid reading from the sensor, as I mentioned earlier. If you've selected open loop mode. If the RPM is higher than the maximum RPM for closed loop mode. If the load is higher than the maximum or lower than the minimum required for closed loop mode, that's another condition. Or if the coolant temperature is lower than the minimum ECT for closed loop fuel control. Now if you've met all these conditions, then the ECU will go into closed loop mode, and you can see this on the closed loop general settings page. You can also see the variables that prevent or allow closed loop operation, so you can see if one of your conditions there isn't right. And also on this page is shown the closed loop fuel trim for each bank. Now the PRD gains can be set against engine RPM. So for example, the engine has got a larger transport delay or longer transport delay at low RPM, so you may need lower gains at low RPM to avoid hunting of the mixture. Now typical values that I've used and work well with widebands are 50% for P, 50% for I and 0% for D. Now another setting that you may want to adjust is the maximum correction percentage. Now this is the amount of additional or less fuel that you can inject based on the closed loop control. So you'd want to set this so that if the sensor goes crazy, it's not going to make the car undrivable. So from factory these are set to 20% usually in OEM cars. I normally set them to 10% because you've tuned this car, but it's really up to you. Now finally, one thing I have to say is that having a closed loop function is not a substitute for having a good fuel map. It's good for correcting for systemic changes that affect the map equally everywhere. But if you have a rich part of one part of the map and you stay there, then the ECU will develop a negative fuel trim value to compensate for it. And then if you accelerate through the map and then you get to a higher RPM point where the map is too lean, then not only is the map too lean, but you've still got the negative percentage which you integrated from before. So it ends up extra lean then, and you may say that, well, this closed loop function is actually making the tune worse because it's being confused by your map, which doesn't actually match the engine. Now, generally what you do is when you're tuning, if you're tuning manually, you'd have closed loop control turned off, and that way you can see what the ECU is actually doing rather than how it's correcting for your errors in the map. Thank you very much.